Welcome to the seminar, and I'm going to be talking about machine learning using Jupyter Notebooks on Gram. Okay, so what is a Jupyter Notebook? It's an open source web application. It allows you to create and share documents that contain live code, equation visualizations, plots, and stuff. And you can also say some text so that you can share with your collaborators and they can run the live coding and then they can see the equation and the visualization. So the uses mainly it's for data cleaning, transformation, data visualization, machine learning, also for sharing with your collaborators. That's the main idea. And also, since it's a web application, you can put it on GitHub or so, and some of your collaborators can see the notebook in there. With that, they don't need to download it and even run it if you don't want them. Also, for today's presentation, I'm going to present the Python data analysis library, so the Pandas. So this is a brief intro. So this is just the way that we're going to load the data. And Pandas is an open source and provides high performance, easy to use data structures for data analysis. This is more for heterogeneous data. So if you have homogeneous data, and in general you have doubles or integers, so probably it's better to use NumPy. But if you have heterogeneous data, when you have a mix between strings and you have floats and you have integers and you have bools, so probably you want to use Pandas. And matplotlib, which is a Python package, it helps you to create 2D plots. In general, it's a 2D plotting. You can also do 3D, but in general, it's a 2D library, so it produces a publication quality figures. I'm going to try to show you how to create such plots in a few minutes. So matplotlib can be used in a Python scripts and a Jupyter Notebook in web application servers, and you can use it, of course, and also in graphical user interface toolkits, something similar like Plotly, interactive way, or even something similar to D3. For machine learning purposes, I'm going to touch only a little bit of Scikit-learn. So Scikit-learn, it's a simple and efficient tool for data mining and data analysis. It's built on top of NumPy, SciPy, and matplotlib. So I'm not going to say much about NumPy, but which is the numerical Python library, and SciPy, which is the scientific Python library. So since Scikit-learn it's built on top of NumPy and SciPy, and as well matplotlib, I'm going to show you how to install NumPy, SciPy, matplotlib, and Scikit-learn. As I mentioned before, so most of the things that we're going to see today is they are open source, but Scikit-learn has been also used in commercial. It has some commercial usage. So if you learn Scikit-learn, so you can apply it on the industry as well, on academia as well. So the mathematical models it has is classification, regression. We're going to touch a little bit of regression, and I'm going to give an example. So clustering, dimensionality reduction, model selection, which I'm going to probably say a little bit of that with regression, and pre-processing. So for classification, you have random forest classifier, the logistic regression classifier, and for regression, you have linear regression, random forest regressor. For clustering, you have k-means, you have the agglomerative clustering. For dimensionality reduction, you have the principal components analysis, and for model selection, you have the cross-validation or the grid search as well. Pre-processing can help you to actually do some scaling of your data before you do machine learning. So that's the idea with pre-processing. So you can do a scaling, or you can try to pre-process the data in a way that you want them the model to behave. So sometimes you want to change the units, or sometimes you want to move from one space to another, and pre-processing can help you for that. So there are some functions already written there, so you don't have to do it yourself. I'm going to move to the demo, which probably is going to take more time. I'm going to use mobile extern because I'm on Windows. But if you do have Linux or Mac OS, so you open up a terminal, in mobile extern, you go ahead and say, give me a terminal. In this case, I'm going to open a tab, and you want to go to Gram. So what is Gram? Is the newest computer that we have. It's located on the University of Waterloo, so here's a nice picture of Gram. And if you go to www.sharcnet.ca/help/index.php/gram, you may find more information about Gram. So for example, the number of CPUs, and it has the number of nodes, and so on. So how to access to Gram? I'm going to go and say SSH, my Compute Canada user, my CCDB basically, username is Jane Andes, add gram.computecanada.ca. Since I set up my SSH keys to the server, so I don't have to type my password. So this is something useful. So if you're going to be entering to the cluster a lot, so the first thing that you want to do once you enter to Gram in order to create your Jupyter notebooks, so you want to check the list, the module list that are loaded by default. So we have few, for example, GCC and Intel, MKL, and so on. But there is no Python module, so I'm going to load the Python module, load Python, and I'm going to use the 3.5.2 version. So you can use the 2.7 as well if you want, but I'm going to use the 3.5 for this demo. So you load the module. Once you load the module, you want to create a Python virtual environment. In that way, you can install whatever you want in that environment. So how to do it? Just say virtual environment, and you want to give a name of your environment. So I want it to be in my home, so I'm going to say home, and I'm going to say Jupyter underscore py3. In case you have a Python 2, so you want to say Jupyter Python 2 and Python 3. So this is just the way to do it. So while installed, so I'm going to tell you about this. So I am actually using this web page, which is the Jupyter, the docs.computecanada.ca/wiki/Jupyter, something that we put together. So it says the installation of Jupyter Notebook, something that I'm going to be doing now. I'm going to follow these instructions. So later on, you can go to this web page and take a look at the instructions in case that you're missing something here. Okay, so when you say virtual environment, you create a virtual environment where you can install any package that you want, and it's not going to be in your session. It's going to be in that particular environment. So in that way, in case you install something not useful, or you're doing something wrong with the Python version in that environment, you can delete the environment and not your session. So because your session may be something different. So how to load the environment? You're going to say source. Since I said that I want it to be in my home, I say my home, Jupyter, Python 3. There is inside a folder bin, and then there is a script called activate. So in this way, I'm going to activate, and note that now my prompt has changed from the regular things that you see in the logging node to some prefix that says Jupyter py3, which is the environment that I just created. Now, here you can install Jupyter. So I say pip install Jupyter, so in a way to be faster. Note the installation has to be in the logging node. if you don't do it in the logging node, so you will not be able to do so. Why? Because you need internet to download all the packages and then install each package. For now, I have cached some of the packages, so it may take some time, but hopefully it's not going to take too much time to get all the packages and then install. As you can see, there are a lot of packages, and if it's the first time that you're doing this, it may take few minutes, or around probably between 5 and 10 minutes, depending on the internet or the connection that we currently have in the server. It may be a little bit saturated and it may take more time, but in general it should be around 5 minutes. Okay, once this ends, we want to install NumPy, which is a numerical Python. We want to install Pandas, and of course we're going to install Scikit-learn. But in order to install those, at least for Scikit-learn, which goes on top of NumPy and also SciPy, we have to install SciPy and matplotlib as well. We're gonna, as I mentioned before, we're gonna use matplotlib to do some visualization, and it's taking its time. Well, I want to explain some. So once you do this, the next thing is to create a wrapper script that is going to launch your Jupyter Notebook. So this is something that we're going to do next as well. And you have to, the script that you're going to create, you want to make it executable. So it's going to be easy for the scheduler to start. There is also the Jupyter L mode. The L mode is the modules, the way we load the modules is L mode. And the version that we have, it's the current version, which is 7.5 or so. And if you want to use Jupyter L mode, which allows you to interact with the environment modules before you launch a kernel. So I'm going to try to give you also a brief demo about how it works. So this is very important. So if you want, this is optional, so you don't have to install this, but I'm going to try to install it anyway. If you want to use RStudio, you can also install RStudio. So this is it starts a session, and then the RStudio session goes through Jupyter Notebook if you have a token, which is something that we're going to see in a few minutes how to do it. Once you are out of the system and then you want to return again, what you want to do first is to load the Python module, which is the one that you used for the installation of this particular environment. Then you do again the source, home, your Python virtual environment folder, and then bin activate. Once you are here, so you will be able to actually start a job. Okay, it's done. So, okay, once we have installed Jupyter Notebook, so we can install the rest of we want. And what I want is NumPy, and also I want matplotlib, and also I want Pandas, and also I want SciPy, and also I want Scikit-learn. So I go ahead. Note that I don't have to say -- user or something else because it's being installed to my virtual environment. In that way, you can install it as if you were in your regular computer. So when you say pip install and the name of the package that you want, or names, in this case I have the NumPy, matplotlib, Pandas, SciPy, and Scikit-learn. Again, it's going to try to collect everything. You need internet, so in the logging node is the way to go. Otherwise, in the compute node, it will not be able to install it unless you have it cached. If it's already in the cache, so you can install it in the compute node. But for now, I'm saying just go for the logging node, so you can install NumPy and the rest. So as always, you may find some requirements which is going to have to be downloaded and installed as well. And when you say installing, so it's not only NumPy that it's going to be installed or matplotlib, so there would be more packages that are going to be installed. Okay, in the meantime, as I mentioned before, so once you load everything, If you want to use RStudio, so you're going to have to load RStudio server. So this is optional, as I mentioned before. And then what you want to do is to start or allocate some time. And you can do it with salloc. So you can, this is an interactive session, so we recommend less than 12 hours. So, and the number of tasks and the number of CPUs per task, so it depends on your requirements, so what you want. In this case, I'm going to ask for only 1 hour, so I get the time a little bit fast. Number of tasks is going to be only one, and I want 2 CPUs per task, and I want basically 1 gig per CPU in memory. Then you have to specify your account, otherwise you will not be able to run anything. It's going to say which account you plan to use. And finally, you run the notebook, a script that we're going to create in a few minutes. Okay, next step would be to create, I'm going to use Nano to create a script that is going to be, I'm going to call it notebook. So I'm going to open up in my virtual environment, and then I'm going to say notebook.sh. In here, I'm going to say that this is a bash script, and I'm going to unset the XDG runtime directory. This is because there has been some reports that when you access to another server, so there are some problems with the path, and then Jupyter cannot initiate because Jupyter is not the owner of the folder. So that's why you unset the runtime directory. So that's the main idea. So you say the IP address that you want to use, and in this case, what I'm going to use is the host name. The -f is going to give me only the domain name, and I'm going to say no browser because I'm going to use my local browser. So I'm just going to initiate the Jupyter Notebook, and then I'm going to use my local browser to actually do something. So the command to start Jupyter Notebook would be Jupyter-notebook. Then you give the IP address so that you know where it is on Gram. And then you say no browser. Why no browser? Because I don't want to initiate any browser on Gram because I'm going to use my local browser. Okay, this and say Control O. I save it. Control X, and then I have I'm going to say chmod user plus X, so I can actually execute this. So the notebook I'm going to create as a script executable. Then after that, I'm going to actually install all the L modes that I mentioned before. So what you're going to have to do is to say pip install Jupyter L mode. In this way, what you do is you download the Jupyter L mode so you can interact with the modules, the Gram modules. So those modules are the regular things that we saw before when you say module list or you say module load this particular module. So this is helpful if you want to load later on a module that you know that it's on Gram, and then you can use it on your Jupyter Notebook. So then you install actually the extension, and after you install the extension in the notebook, then you enable the extension, and finally you also enable the server extension. One is for the notebook and the other one for the server. So you load all of them, and now we are actually good to go. Once we have everything, I can say alloc. So I'm going to allocate the time. I'm going to say the time that I want, which in this case it's going to be 1 hour because in any ways 1 hour is going to be 120. So the demo is already done. So I want only 1 hour, and then I say --n tasks. So I want only one task. I want 2 CPUs per task. So I say CPUs per task 2. And I want the memory per CPU to be 1 gig. Then I have to say my account, which in this case is Jane Andes. So I say my account, what I'm going to be using. srun is going to help you to initiate everything in parallel. And then I have to say where it is. So my script is in virtual environment, then, and it's notebook. So I start this virtual environment. So I start this, I try to give the allocation. It's going to say pending job allocation. Then it's going to say the number of the job ID, which is this number. Then it says it's going to be at a certain time, depending on how busy Graham is, it's going to say queued and waiting for the resources. But if you get granted this particular job, which was almost immediately, says it's granted job, the location is the job ID, and then now you're good to go. Note that then it takes some time to start the Jupyter Notebook. So it says loading L-mode extension. This is the way we're going to interact with the modules. And then it says where I am. It says that I'm local directory is home, Jane Andes. And then it says where it's running. So this is the domain that I mentioned before, which is gram797 gram.sharcnet. And this is the port. Also send a token. The token is a way to say how secure your notebook is. So you give me the token, which is kind of your password, and then you can access to it. So you have to copy and paste this token as well. Okay. So I have to basically copy and paste this. But note, if I do this, I'm going to have a trouble with my browser. Why? Because I have to tunnel this to my local computer. So, and I can even show you what happens if I do this. So I say, I'm going to copy, and I'm going to paste it to my local browser. So if I say go, so it's going to say the server not found. What I have to do now is to create another. I have to open up another terminal, and in that another terminal, I'm gonna say that I'm gonna tunnel that particular server that I had. So what I'm gonna do is SSH-L. My local port is gonna be 88848. So this is my local port. Then I have to specify the rest, and the rest was given by Jupyter Notebook, which says that is gram797.gram, and this is the port. I'm choosing exactly the same port. I could choose something else, let's say 7777 or something different, but I want to choose exactly the same port, so I know that I am in Jupyter Notebook from Gram, this particular thing. So you say the domain and also the port, and I have to access to Gram. So I say my username gram.computecanada.ca. I say enter. It's going to access now. As you can see, you can add -N, and it's not going to enter to the cluster. It's just going to be without the prompt. So now I have the token. I have copy and paste this, which was not working. But note that this thing, this complete link, was now it's being forwarded from the cluster to my local computer in the port 8888. But now this is my local computer, so I'm going to have to substitute this gram797.gram.sharcnet by local host. This local host is actually my computer that is going to be port forwarding this 8888 port to the gar797.gram.sharcnet column, the port 8888. So this is the main idea. So now that I can access to Gram, so I can open up one folder. If you want, I'm going to use the Scikit-learn folder that I already have, and you can say new Python 3. So then you're going to create a notebook. In this way, I don't have time to open up a new notebook and then type everything. So I created already one that it's Intro to Machine Learning. Note that the extension is IPython, so the notebook Python, IPython Notebook. So in here, you can interact with the cell. Note that here you can change the type of the cell. Could be code for live coding, could be markdown, in this case for text. So I'm going to say here, you can edit everything that you want, and so you can learn more about markdown later on. So if I say Shift Enter, so it's going to run, and now you have this. What we're going to do now is to do some prediction about power plant usage. So there is a data set in the archive from the University of California. I think it's the Davis, but then there is this data set with more than 9,000 data points collected from a combined cycle power plant over 6 years. So what's the idea? The idea is that they measure temperature, ambient pressure, relative humidity, and the exhaust vacuum in the plant where they're working. And with that, they try to predict the hourly electric energy output. So this is the idea. Based on the temperature, pressure, relative humidity, and also exhaust vacuum, how much energy I have to generate for that particular hour or for that particular day. So this is the idea. So they collected that, and the temperature is given in Celsius, goes in a range between almost 2 and 37 Celsius. Ambient pressure, there is in millibars, and the relative humidity is in a percentage, and then the exhaust vacuum is in centimeters of mercury. So based on that, I want to predict the electric energy that I have to create, which is going to be given in megawatts. So that's the idea. So this is the goal. I have to load some of the libraries. I'm going to use the Scikit-learn ensemble, which is a random forest regressor. I'm going to use the model selection. This is for train, test, split, and also cross-validation. I'm not going to probably use the cross-validation, so I'm going to get rid of it. And then I'm going to say grid search, cross-validation. I'm going to also test the linear model. What happens with that? This is a linear regression. I'm going to use Pandas to load the data, and matplotlib to actually see the data, so what's happening, so visualize some of the data. So once you run this, you say Shift Enter. If you take a look now at this, it's going to be saying that it starts a kernel, then it says adapting to certain protocol, and automatically it's going to save the file in that particular, the same place that I'm saying. So there's going to be some auto saves from Jupyter. So now you can see that the one is done. So here shows if it's a solid, so it means it's running. I'm going to use matplotlib inline to show all the plots in here in my web browser, so I don't have to show them somewhere else. I'm going to load the data, which is actually in my workspace. It's in www.sharcnet.ca/tilde Powered Data. It's a CSV. I load the data with Pandas, so I say Pandas read CSV. I want to show you quickly what the data looks like. So the data is a temperature, and then I have temperatures, then the vacuum, then the ambient pressure, relative humidity, and finally the electric power. So this is, I have my 5 columns. So if I want to plot this, so I can say data, which is actually the name of my variable where my data is. I can say dot plot. The kind of data is going to be scatter. X is going to be T, and Y is going to be the electrical energy output, and I'm going to give some size. So the idea with this is that you use Pandas to plot with matplotlib. So you don't have to say matplotlib or plt dot plot or dot scatter. So you can use Pandas to do that. So here we can see that there seems to be a linear relationship between the power energy and the temperature. So then you can do some stats with Pandas. So I can say data.describe. So I'm going to give you some count. If the count is exactly the same for all the columns, that means that there is no missing values. So in this case, all are the same, so there is no missing values. And then you can find the mean, the standard deviation, the mean, 25 percentile, 50% percentile, 75% percentile. So then you have the maximum as well in the column, and this is for each column. So this is the idea. So you can see that the maximum temperature in basically 6 years was 37 Celsius, and the minimum was 1.81. So since this plant is from California, so now you understand. So probably it's Southern California. So because in Canada, you're not going to have a minimum of 1.81 Celsius. So it's just going to be, depending on where you are, could be minus 40, minus 20. You can even check correlation. You can say data.core. So it's going to show you correlation between all the columns. And yes, indeed, it seems to be a linear correlation between the temperature and the power output. So, which is, it seems to be a negative, but which is something that we can see here that goes like this. It seems to be a linear. So, but then there are different ones. For example, there seems to be some also correlation between the temperature and the vacuum, and also with the ambient pressure, and also with the relative humidity. So I'm not going to run this because it may take some time to run. But okay, so then in machine learning, what you want to do is, once you get a data set, you want to split the data into training and test data set. So why? Because you're going to train your model with some particular set, and then you're going to test if this module is good with some portion of the data. In this case, it's going to be the testing data set. So what I'm going to do is I'm going to create my X, and it's going to be the T, V, AP, and RH. So basically the temperature, vacuum, ambient pressure, and relative humidity. And Y is going to be the power energy. So I'm going to use train test the split, giving X, Y, and certain test size, which is going to be 30% of the data. And I'm going to say the random state of 100. So if you run this, you can see exactly the same thing that I have. So I run it. Now I split the data into training and test sets. So just to take a look, the total records are 38,000, more than 38,000, and for the training it's basically more than 26,000. So, but you can see that I have a split part of my data set. So I have the training part and I have the test, a way to check or validate my model. Since I saw some linear trends, so I can say, okay, let's take a look at the linear regression. So since I asked for 2 CPUs per task, so I can say I have 2 cores. I'm going to use n jobs equals 2, so to generate or to use the 2 cores that I have and run them simultaneously in my linear regression. So Scikit-learn has this ability to run in parallel. So if I have 2 processors, I can use the 2 processors using n jobs equals 2. So I'm going to run this. So I create my linear model, and then I'm going to train my model using my train and my train set. I can take a look at the coefficients, and yes, it seems that the temperature is the one that is dominating in general. And then what I can do is I can do some the predictions or so, but so if I run it, so I'm going to get back the prediction, so something that I'm going to give. But what you want to also do is to check the score, which in this case is going to be the coefficient on determination. So just to take a look at how good my model is, the respect with my test data. So I'm going to use my test data, I'm going to run it, and it says that 0.92. It's not bad, but it's still, what you want is to predict better. So it's not bad, it's fair, but probably you want to test something else in case you get a new, better model. So I can get my predictions. I can do give me the predictions based on my test model, and here I can use tech or LaTeX for my plots, and I want to plot the y-test. Y-test is the real data that I have against my predicted data, so I can take a look at what's going to happen with my data, so how good it is. So this is the real data, and here's the predicted data. So as you can see, well, it seems to be a linear, so, but it still is some scattering. You can see some scattering, so it's not bad, but probably you want to do better with some other modules. So this model that I'm going to use, it's a random forest regressor. So this is the next one I'm going to test. I'm going to create this, and with the random forest regressor, and just to show you, there are many parameters that you can change just to make your model a bit better. So, but I'm going to fit with the training data the same way I did with the linear regression. And now my R model, the RF module should be exactly the same that the previous, which is the same. I can take a look at the feature importance. This is something that random forest has, and it's going to say that the feature importance, yes, of course, again, it's a temperature. It seems that the temperature is the one that's going to change the power, the output. I can take a look at my score, and my score is 0.997 in the determination coefficient. So it's a better coefficient of determination. So that means that the random forest is a better model than the linear regression. I just want to take a look at how it's done, and yes, it's more linear. You can still see some scattering, but not that much as the linear regression. If we go back, so you can see this is for the linear regression, and this is for the random forest. So it's much better. Still, you want to take a look at if your model is actually doing quite well or not, or you may want to play a little bit with the parameters. If you want to do that, you can use the cross-validation. Cross-validation is going to now get the training data, split the training data multiple times, so you can get two sets in the training data. One is going to be for training and the other for validation, and you still keep the test data set in another place. So at the end, the whole data set is going to be split in three. One is going to be for training, one is going to be for validation of the training, and at the end you're going to score with the test data set. So this is the idea with cross-validation. And with grid search, what you can do is to change the parameters and run each parameter or different parameters so that you can get a better model with different parameters. So what I'm going to change now, just not to take too much time, is the estimators. So I'm going to, by default, the n estimators in random forest is 10, so I'm going to change it to 50 and 100. The more you get, the better, but this is just a way to test a little bit how it works. Then you can set the parameters. If you remember the random forest models, I didn't say anything about n jobs, so or the number of jobs in parallel that's going to be running. If you say equals to -1, it's going to take all the resources that you're giving them. If you are running on your local computer, you probably want to say n jobs equals to 2 if you have four processors. You don't want to use all your processors, otherwise you will not be able to see your Firefox or something else. But on the cluster, you want to use all the resources so that you don't request 8 processors and you're using only 2. You want to use the 8 processor, so that's why you say -1, because I want to use all the resources I'm asking for. So in this case, on RAM. Note that it says n jobs equals to -1, so -1 is going to take all the resources again. So in the grid search, I'm going to give the model, which is the random forest, the parameters that I want to change, which was in the estimators only, and it's going to run 3 times. And then I'm going to give the cross-validation. The cross-validation 5 means the training set is going to be split 5 times in random ways, so then the training and the validation can be done at once. And at the end, I'm going to get the best model or I'm going to get the score to see how it's going to be in real life. And then I'm going to return the training score. So I want to take a look at that. So I run it, and then I take a look at my model, and my model now it says cross-validation 5, and it says in pre-dispatch, it says 2 times n jobs. So in this case, it added 2 because I have 2 processors. That's why it says n jobs. Okay, so now I can run this. Note that the percentage time, it's gonna time the cell. So this is a magic cell as well, and it's gonna try to time this. And at here, I'm gonna say the grid with the grid search fit my X train and my Y train based on my training set. So what is gonna happen now? It's gonna do the cross validation 5 times, and it's gonna use all the resources that I requested for. So on Gram, so I requested 2, if you remember when I said CPU per task equals 2. So I'm going to use the 2 processors, so I don't have idle processors there. At the end, it says that the total time was 1 minute and 13 seconds, but the goal time was 40 seconds. It's not exactly half of the time, so it's still 1.8 or so, the speed up. It should be 2. That's theoretically. In reality, it never happens. So if I had 8 processors now, this time could be almost divided by 8, which at the end could be more than divided by 7. But so that's actually quite good. So I'm speeding up my machine learning model using n jobs. So it's running on parallel. So I want to take a look at the cross-validation. In the cross-validation, if you remember, I had only 3 parameters to check, the 10, 50, and 100 for n estimators, and it's going to return the rank test, so 3, 2, 1, so the best is for n estimators 100, and it gives me also the fitting time in seconds, so it took more time to fit an n estimators equals 100 than an n estimators equal 10. And then there is the mean test score, so which of them perform best, and in this case again is the n estimated 100, and it's exactly the same for the training and for the test scores. So you can take a look at the splits, split 0, 1, 2, and 5, so because I say CV equals 5. Okay, so I got my best estimator, but how do I really get it? So what I'm going to say is that dot best estimator. So that's going to be my best estimator, and it says that this n estimated equals 100, which that was the best. I'm going to save this as a best model, so I'm going to say best model equals to the best estimator. I want to score it, and the score is 0.9977, so it's a bit better than the first one. So now I want to take a look at the visualization, and it looks very similar to the previous random forest model, yes, but less scattering probably, not that much. But if I go back, so you can see here, so it seems to be fine, some scattering as well, and here some scattering, but a little bit less. Still, both models are quite good, and that's the thing. If you want to predict a single, so let's say that the temperature is 11 and you have a vacuum of 70, which is in general what you get, and then you have some certain, so for example, in London, Ontario right now is 8 degrees and you have 100.6 kilopascal and you have the humidity to be 65. So what I'm going to have to do is 8 degrees, the exhaust vacuum is about 70 in general, and then it's going to be 1006 because it's in millibars, and then it's 64 relative humidity. So if I run it now, I get that the power energy needed, if I were actually in California, would be 478 megawatts per hour. So that's the idea. So this is the end of the machine learning part. What I want to show you to finalize this is how to close, you say close and hold, So I kind of close and hold my notebook, and I'm going to show you how to load modules or how to interact with the module from Gram. So you have files running and cluster. This is from Jupyter, and then I say software. Note that this is my loaded modules currently. I have the Python 3.5.2 that I loaded, but what if I want to load another one, such as Spark 2.2.0? If I select this and say enter, now it's going to load this module, and now I can use it, and I'm going to give you a really quick test how to use. So on my interactive session, I can also run bash scripts. So I can say %bash, and this is going to be run on the bash. And you can even say time and see how long it takes. So this is the Spark. This is running on the command line. But also, since I loaded the module once I was on Jupyter, now it's available on my notebook. It was not available before. So now I can take a look at how to start a Spark session, and then I create a Spark release session, getting the resources. It's going to get the 2 processors that I mentioned before. The version is 2. Now this is running on Jupyter Notebook or Python in this case. So this is the idea. Now you can interact with modules. If you go back and go to software, if there is another module that you want to load, you can say it here. You can say R module. So I want the 3.4 version, and you can load the R module if you want to use it later on your Jupyter Notebook. And for the moment, I think this is good for today, because otherwise I'm going to keep talking, and it's already 12:50, and I'm good for questions now.